In this video, I'm going over our quiz number 1 questions. And again, the questions, so remember here, I follow version A, so make sure if you have a different version, the numbers are given to you. So if you ever need to pause the video to find that question number, of course, go ahead and make sure you do that to give you some time. So with question number 1, notice how we're just given this information. However, we are looking for this expression given, which is equivalent here. So writing this expression here in radical form. Well, first off, notice how the exponent is positive. So did you need to reciprocate the base or flip the base to make a fraction? No, because the exponent is still positive. So the answer is not A or B. So now looking here, also notice how the negative is outside of F, like as if this is a -1 times that. So because this is not all together, that's -1 times all this, that negative here is on the outside, so it needs to be on the outside of the radical, which is why the answer was D. So question number 2. Notice how here you're given a fraction, you're dividing. So with our bases, when being the same and we're dividing, make sure from top to bottom to subtract the exponent. So let's first start with the base of 3. We are taking 1/5 minus -2/5. Make sure, and if you need to, write it out. So this actually ends up giving you 3 to the +3/5. That's 1/5 minus a -2/5, which is the same as two negatives also making a positive. So 1/5 plus 2/5, which is again 3/5. So I know the answer is not D because that's 1/5. And here the answer is not A. The answer is also technically not B either because the 3/5 here is in the denominator as if this was a negative exponent. So let's just again continue on to make sure that the answer is C. With a base of 7, subtract the exponent, so 5/3 minus 4/3, which is 1/3. So that's here the answer, which is C. Now look for your question number 3 on your version. And here we're solving for x. Well, notice how both sides of the equation do have that cubed root. So to get rid of the radical, we're going to raise both sides to the third power. So now that the third power has been raised, both sides, the radical cancels out, and we're left with solving 5x plus 10, which is equal to x minus 4. Notice how you have variables on both sides, so I'm going to gather and subtract x here. Now I've got 4x plus 10, which is equal to -4. Now I go through and solve my 2 steps. Subtract 10. So now I've got 4x, which is equal to -14. Then divide both sides by 4, and x is equal to, now yes, you have this negative fraction here, which both values, this can be simplified because they're both even, and you end up with -7/2. Now, this question, so look for the version, and you're looking to see what mistake was made. So I noticed first off, and I'm going to go through as if I were to solve this, and if you were to raise both sides, right? We raised both sides to the second power, which was done. So then if I were to continue solving this, I now have the radical cancel out, and I'm left with 8 minus 2x, which is equal to, remember that's x minus 4 to the second power, so we do need to do box method. So that's x minus 4 times itself, x minus 4, which gives you x squared, then -4x, -4x, and +16. So after combining like terms, you have x squared minus 8x plus 16. So does everything match? Yes. So far, so good. However, when solving a quadratic, it has to equal 0. So I'm going to subtract 8, line up the like terms, and add 2x. Line up the like terms. So now we're going to solve x squared minus 6x plus 8. So does that match? Yes. So now we're going to solve by factoring. What factors multiply to get positive 8, and add to get negative 6. Negative 4 and negative 2. So does that match? Yes. X is equal to positive 4 and positive 2. However, remember when raising that even, we always need to check to see if either of them are extraneous. So I'm going to go ahead and check 4. So I'm going to use that first line here. So the square root, so let me go ahead and erase this here so I can show and see. So 8 minus 2x, or 2 times 4, which is equal to 4, or x minus 4, or 4 minus 4. So now here, first off, I've got 4 minus 4, which is 0, nothing negative, so I'm good. I'm going to keep going. Make sure that this matches. So now inside I have 8 minus, well, that's just 8. And the square root of 0, well, that's just 0. So far, 4 is a solution. It's not extraneous. Now let's check 2 here. So here I've got the square root of 8 minus 2 now, but times 2, because that's what we're checking, is equal to 2 minus 4. So instead of x minus 4, 2 minus 4. 2 minus 4 is negative 2. Oh, what do you notice? We got a negative. And remember, when we're taking the square root, we always focus on the positive. So 2 is actually extraneous. So that is the error, because she stated that both 4 and 2 are a solution, but 4 is not, or 2 is not. It's extraneous, because remember, this is the square root of 4, which we're focusing on, which is just positive 2, not equaling to negative 2. That means that's why here the answer was B. So now look for question number 5. And here we go. Well, notice your answer choices. We are needing the exponent. So I'm going to go ahead and rewrite each of these as an x in exponential form. Remember, this is a square root, which has that understood index of a 2. So again, the square root has an index of 2. So this is y to the 5 over 2, not 5 over 1, times y to the 8 over 2. And if you recall, when multiplying, we don't multiply, we add the exponents. So that's why here the answer was B, 13 over 2. Now in this equation, we're going to go ahead and solve for x. Notice again how we have the radical here. It is all by itself, so I'm going to go ahead, get rid of the radical, square both sides. So now my square root, my radical is gone, and now I'm left with 3x minus 8, which is equal to, however, again, you have x minus 2, this binomial being raised to the second power. So again, you do need to do box method. So this is x minus 2 times x minus 2. So here I've got x squared, negative 2x, negative 2x, and positive 4. But after combining like terms here on the diagonal, you have x squared minus 4x plus 4 now. But remember, you're solving a quadratic, so x squared here, which always has to equal 0. So now here I'm going to subtract 3x from both sides, as well as add 8 to both sides. Now I've got x squared minus 7x plus 12. Now solving by factoring, what two numbers multiply to get positive 12 and add to get negative 7? Negative 4 and negative 3, which means x is equal to 4 and 3. But again, when squaring, we need to check to see if there's either are extraneous. So I'm going to go and plug in. Let's start with 4. So the square root of 3 times x, or 3 times 4, minus 8, which is equal to x, or again, 4 minus 2. So here, 4 minus 2 is 2, so far so good. Now here I've got 12 minus 8, which is the square root of 4, and the square root of 4 is 2. So far, 4 is a solution. So now let's check if 3 is also a solution. So the square root of 3 times x, or 3 times 3 now, minus 8, which is equal to x, which is again 3 minus 2. So 3 minus 2 is 1, positive 1. So again, so far so good. And now I've got 9 minus 8, which is 1. And the square root of 1 is 1. So both match up. So that's why the answer was A, both 3 and 4. Now question number 7. Again, look for this one on your version. But notice how you have this value here, x plus 3, all being raised to the 1/3 power. However, right now it's being multiplied by 2. So this first step was actually to get rid of that, get the parentheses by itself and divide by 2. So really the equation you end up solving here is 3 is equal to x plus 3 to the 1/3 power. Now we can do the reciprocal of 1/3, which is raising both sides to the 3rd power. So now the powers cancel out, and I just bring down x plus 3, which is equal to 3 to the 3rd power. Remember, guys, that's not 9, because that's 3 times 3 times 3, which gives you 27. So now you need to solve for x, subtract 3, and that's how you get x is equal to 24, which leaves you with A. So then question number 8, same thing here. I can't get rid of the radical yet because right now there's this value, 13, is being added to the outside of it. So we've got to get the radical by itself. So you first need to subtract 13 here from both sides, leaving you with the square root of 4x minus 9, but which is now equal to 3. Now I can get rid of the radical and square both sides of my equation. Now this cancels out and I'm left with 4x minus 9, which is equal to, well, 3 squared, which is 9. Now we're going to go through and solve for x the two-step. Add 9 to both sides. Now I've got 4x is equal to 18. Divide both sides by 4. And here you've got x is equal to, this fraction can be simplified. They're both even, so by 2. And that's why you get 9/2. Last two questions here. So question number 9, again, look for this version or the question on your version. And here, now notice first off, see how everything 6x is all together inside. That means if it's all together inside the parentheses, then it needs to be all together inside of the radical. So I'm going to go ahead and mark off A and B because the 6, this value here, is on the outside. Then remember here, that 6x is like it's being raised to the 7th power because the numerator is always the exponent. So that's 6x to the 7th power inside of the cubed root. That's why the answer is C. Last question, number 10. So again, you're solving this equation here. But notice how, so I'm going to go ahead and just, you know what, let's go ahead and rewrite it so I can see. So here I've got the square root of 7x plus 4, which is equal to 24. Should you square both sides first? No, because it's being multiplied by 8. Notice how this value of 8 that's being multiplied is outside. So you first need to divide both sides by 8, which leaves you with the square root of 7x plus 4, which is now equal to 3. Does this match? No, it doesn't. That is the error. If you notice, what do you think they had to do to go from 24 to 16? They subtracted 8 when you were supposed to divide by 8 to get 3 and not 16. That's why the answer was A.